Chapter 6 Transmission of Electrical Energy 6.1 Alternating Currents. Let's begin. Patterns formed by light-emitting diodes. Light-emitting diodes glows when current flows in one specific direction. When an AC flows through a LED, the LED flashes at the frequency of the AC. When a camera moving horizontally takes a photo of the two LEDs here, we can see why it's actually flashing, turning on and off continuously. 1. Alternating currents and EMF. An center serial ammeter and a CRO are used to observe the voltage variation of an AC. Video 6.1 Experiment 6a Current and EMF produced by a small AC generator.
We will study the EMF produced by a small dynamo. A dynamo is a small AC generator which has a fixed coil on a soft iron C core and a rotating permanent magnet. The rotation of the magnet produces an induced EMF across the coil. The induced EMF drives an induced current in a closed circuit. Turn an AC dynamo slowly and then quickly to light up a lamp. How does the brightness of the lamp change when the dynamo is turned faster? Connect the dynamo to a center zero milliammeter. First, turn the dynamo slowly, then slightly faster. The milliammeter pointer deflects to and fro about the center zero of the scale slightly. Connect the dynamo to a CRO and turn it steadily at a high speed. Observe the waveform on the CRO screen. How does the waveform shown on the CRO look?
The magnitude and direction of current changes periodically. The waveform shown on the CRO is a voltage time graph of the AC. We can measure the period and peak voltage of the AC from the waveform. From the period, we can also calculate the frequency, which is the number of complete cycles per second, using the formula F equals 1 over T. A. Sinusoidal AC. A sinusoidal AC has a sine wave-like voltage variation. For the sinusoidal AC, when the voltage output is set to be 5 volts, the peak voltage will be 5 multiplied with root 2 volts. In other words, they are different by the factor of root 2. B. Other forms of AC. There are also square wave, triangular wave, and sawtooth wave available from some low-tension power supply. In short, an AC has a current alternates in different directions. 2. Direct currents and EMF. DC flows in one direction only. The magnitude of a DC may change, but it never changes in direction. A. Steady DC. A steady DC flows in one direction and it also has a constant voltage. Voltage output from a battery is a steady DC. B. Varying DC. A varying DC has a changing magnitude. It may have any shape as far as that magnitude is not constant. The most common varying DC looks like that on figure 6.1e, which is converted from an AC using a diode. Example 1. Explain the different patterns formed by LEDs. These LEDs X and Y are connected in parallel in opposite directions. You may now able to explain why LED Y appears flashing when an AC passes through it. Do check point 1 below.